So in this session, we'll discuss the doubts from topic intermolecular forces. The doubts from this assignment, question 9, 25, 34, and 42. So we're starting with question 9. So as you can see, the viscosity of four liquid organic compounds are compared by placing the liquids in a separate identical tube and each with air bubble at the top. The tube is inverted, and the time measured for an air bubble to travel. For which compound does the air bubble take the longest time? So basically, it depends on the intermolecular force. If the molecules have a stronger intermolecular force, as a result, what will happen? The air bubbles does not find it space to move easily. So this one will have, like OH is there, so it will form one hydrogen bond. This will form two hydrogen bonds. This will form three hydrogen bonds. And this one is not having, hydrogen is not attached to most electronegative elements such as oxygen, nitrogen, or fluorine. So it will have a dipole-dipole forces, the strongest one, but not the hydrogen bond. So option C is the right one because it can form three hydrogen bonds. As a result, there will be a strong force of attraction between the particles or molecules. So air bubble cannot pass easily. Next is question number 25. So in question 25, which of the following compound has the highest boiling temperature? Look, the boiling temperature depends on the intermolecular forces or the force of attraction between the molecules. So when we check, cyclopentane will have induced dipole force. Pentane will have induced dipole force. Butane 1-ol will have hydrogen bond. And ethane 1,2-diol will also have hydrogen bond, but this will have two OH groups, so it will form two hydrogen bond. This will form one hydrogen bond. And the strength, when we compare, if the hydrogen bonds are stronger than dipole-dipole forces, and dipole-dipole forces are stronger than dipole-induced dipole forces when they have the same number of electrons in the molecule. This is a comparative, but hydrogen bond is the strongest one. So ethane 1,2-diol, it is having two OH groups. As a result, it can form two hydrogen bonds. That's why option D is the right one. Next is question 34. In question 34, sodium chloride is more soluble in water than in hexane. So what is the reason why the solubility of a sodium chloride is more in water compared to hexane? Because when ionic compounds mix in water, so these ions are surrounded by water molecule. So sodium will be a positive ion that is surrounded by oxygen, which is partial negative. And the chloride ion, the negative ion, is surrounded by partial positive hydrogen. And when these water molecules surround these ions, the bond forming is there, and bond forming is exothermic. So as a result, it will release energy, and that energy is called hydration energy. So when sodium chloride, NaCl, dissolve in water or mix in water, due to the hydration energy or due to the formation of the bond or attraction between the water molecule and the ions, it releases energy. And if that hydration energy is more than the lattice energy, these ions are separated from each other. As a result, this ionic compound will dissolve. So energy is released when these ions in sodium and chloride are hydrated, and that energy is responsible for separating the ions and make this ionic compound soluble. Next is question 42. By considering the intermolecular forces involved, explain why methane has a boiling point of 109 Kelvin, where ammonia has a boiling point of 240 Kelvin. Although these two compounds have the similar molar mass, like methane is their CH4, so the molar mass, it has one carbon and four hydrogens, so 16, and ammonia is there, which is NH3. With a molar mass, nitrogen is 14 plus 3, 17 will be the, so 16 and 17 relative molar mass is same. But why? So when we check the type of intermolecular force, the force of attraction in methane, as there are no dipoles, so it will have dipole-induced dipole forces. So in case of methane, it will have dipole-induced dipole. Whereas in case of ammonia, hydrogen is bonded to most electronegative elements such as nitrogen, or more electronegative elements such as nitrogen. So as a result, what will happen? They will have hydrogen bond, and hydrogen bonds are stronger than the dipole induced dipole forces. So, or you can also say London dispersion forces. So, in case of ammonia, it will have a hydrogen bond, where it will have London dispersion forces or dipole induced dipole forces. And dipole induced hydrogen bonds are much stronger compared to dipole induced dipole forces. So, as a result, means greater amount of energy is needed to separate the nitrogen molecules from each other compared. And why there is a hydrogen bond? Because hydrogen here attached to more electronegative element, and that is responsible for hydrogen bond. Here, why there is no hydrogen bond, even hydrogen? So they have the similar electronegativity. So similar electronegativity for carbon and hydrogen. As a result, the bonds are non-polar, which leads to a formation of a dipole-induced dipole forces. So these are the points you should include, and these are the doubts related to assignment and intermolecular forces.